Hi guys, this is just a short video just to go through the Shear Force laboratory. So what we have here is the Shear Force device. What it does is it takes a beam, the beam is cut into two sections, and then a setup, mechanical setup is used to support both the bending moment and the shear force. On this device there is a spring gauge. The spring gauge here is used to both support the shear force and also to measure the amount of shear force of this gauge here at the moment. Okay, so the first step in doing this experiment is to check that the device is level. This has previously been done, but on the front and on the backs of our device here we have adjustment knobs which are used to lift up little foot supports in the front and in the back of the shear force device. Our second step is to check that the distance between the right hand support and the left hand support is exactly 0.9 meters. So this is to match the data which is in your lab sheet at the moment. So we can take a ruler, measure between the pins at these 2 points using our ruler, and we get 90 centimeters. The next step is to check that the cut in our beam is the same as the value which is in our lab sheet. At the moment this is set to be 0.3 meters away from the left hand end. So we take our ruler, we see a gap in the center of our component, and as I see that I need to move this a little bit to the right, so I take the beam and I shift the whole assembly towards the right hand side until it reaches the 30 millimeter mark. Our next step is to check that the hangers are in the correct locations. So I'll move this to a position of 0.1 meter away. The second support I'll move to a position of 0.31 away from our support, basically on top of this circular recess. And our third support I'll move to a position which is 0.5 away from the left hand support. So I'll take my ruler, measure a distance of 0.5 and place the support at that position. Once we've placed the hangers in the correct place, the next step is to check and ensure that our beam is parallel with the surface. So to do this, what we mean by parallel is instead of being at an angle, we can make it parallel with this surface at the base. So we do this using our eyes at this stage, and we adjust the underslung spring to ensure that it's parallel. So it's roughly parallel. Around about now. So you can use various strategies to ensure that it's parallel. If you can put a board or something similar in the back which has a straight line which you can use as a reference. The next step is to adjust the knob on top of the spring gauge until both sides of our beam are collinear, are in line with one another. So for example, the first step, make sure that each of our sections are parallel with the surface, and the second step is to ensure that they line up, that they're collinear. So we'll adjust this knob. until the two marks, the white sections, line up with one another. So at this point I read a value off my spring gauge. At this point I want to remind you that the spring gauge is the most accurate reading you can get is accurate to 0.5 of a Newton. There's an error of about 0.5 of a Newton either way for each of our values. So the value which we read here is 3 Newtons plus or minus 0.5 of a Newton. Alright, so now we've got our reference value. While we're doing this, we need to check that our supports have not moved at all. So I'll just double check that they have not moved. It appears that this has moved just a little bit, and our other component has stayed pretty much in the same place. Alright, and our next step is to place, we recorded our value. Next step is to place weights onto our component according to the table which has been provided to you. So our first location is a mass which needs to be placed 0.1 away from the left hand end, and we need to place a 10 Newton load. So we take our masses and we take a 10 Newton load, place it at the end which we would like to measure. You'll see our setup will change. So the beam will change from being collinear and parallel to having some kind of deformation. Now we will be adjusting our setup to go parallel and then collinear again. So we will adjust the underslung spring to make it parallel, and then now adjust our spring gauge to obtain a new value of shear force on our setup. Now we'll read off the value of shear force off our spring gauge, and at this point we read a value of about 2 Newtons, and we can record that value. Now we'll repeat this for all of the different weight combinations that are provided. So at present the next one would be taking our weight and moving the weight, placing another 10 Newton weight on our component at this left hand side. And we can repeat the process by adjusting the underslung spring, and then by adjusting our spring gauge, to measure our force. So we'll need to repeat this until all measurements are obtained, and if you have time you can try to go through and do the experiment a second time, just to try to reduce the effect of experimental error in your experiment, and so that you can see where outliers are inside your experiment. Alright, so your next step will be to compare your experimental and theoretical results, and we'll look at that in another video. Thanks for your attention.